Okay guys, today we're going to finish doing some elimination method. This time we're going to end up using multiplication to help us with the elimination process. These are 3 examples out of our toolkit, so these are in your notes, in your toolkit at the bottom. On all the previous examples, you noticed that we had opposites or exactly the same that you could add or subtract. But on this one, you notice that that does not happen. So what we're going to do is we're going to force equation 1 and equation 2 to have either opposites or the same by multiplying one equation by a constant factor. Let's see what this looks like. Alright, so I'm going to multiply the bottom equation by 2, and what's going to happen, I'll just rewrite that. Alright, you can see I just distributed that out and got 2x plus 10y equals 4. I just copied the top equation again. I didn't do anything fancy to that. And now you recognize from yesterday that you have the x's are exactly the same. And we remember that the same we're going to subtract. So I'm going to subtract those two and use my elimination method. Alright. From here on out, it's really just the same elimination method that you used yesterday. I'm going to take this y, I'm going to plug it back into either equation. Actually, I have many equations to choose from. I'm going to choose this equation, this bottom one though. It seems to be the easiest. And then find the corresponding x that goes with that y. And again, it's just like our elimination method from yesterday. So you guys can hit pause as much as you need and watch this. Alright, pretty straightforward. Alright, what I'm doing now is I'm actually going back to the same problem. On the last one, I multiplied it by 2. But someone noticed that, hey, if I would have multiplied it by a negative 2, then these two signs would have been opposites of each other. So why do I like that? Well, I like that because generally speaking, I'd rather add than subtract anyway. So 2x plus negative 2x ends up being 0x, and now I can use my elimination method with addition instead of subtraction. Notice it's the same exact problem, and you can kind of see that you're going to end up with the same results. But I know that a lot of people do prefer addition over subtraction, so by multiplying by the negative 2, that allowed that to happen. So really you have a lot of flexibility in this. We'll check out the next one. Okay, all we're doing here. Alright, so we notice on this one, if I multiply the bottom times negative 2, you can see that you will have opposites here, and then it is totally solvable. But I could also multiply it times positive 2, and this time I could subtract them, and that's just the flexibility that you have. So that's multiplying the bottom. Further, I can look at it. I'm not going to solve it that way, but further I could look at it. I could actually multiply the top equation by positive 2, and this time the y's end up being opposites. Or I could do it by negative 2, and now I can use the addition. So as you can see, there's 4 different ways I can do this problem. It's really totally up to you which way you think is going to be the easiest. I think we chose to do the negative 2 on top, and you can follow through and watch the solution. our last example here, we end up with a situation where neither equation is immediately an opposite of the other. So actually I'm going to end up multiplying both equations by trying to find the same one. There are different ways I can do this. I can multiply the top and the bottom, the top by 5 and the bottom by 4. And what's going to happen there is my x's will end up being opposites of each other, or actually the same in this case. Sorry for my bad arithmetic. Okay. I'll back that up just a hair, I hope. Alright, so you can see that now these are the same, and I could subtract them. But as you saw on the other two examples over here, personally, I would rather add the elimination method. So I'm going to multiply the bottom equation times -4 instead of +4, and just adjust that right here. And now it should make it much easier to solve. That would have been one way of doing it. The another way is I could have gotten rid of the y's. So here's what it would look like if I set up the y's. And I must not have finished solving that one. But that's all right. The idea was the same. If we go back to this one, what I could do at this point is I could finish solving here. Oops, that didn't work for me, sorry. Okay, now I can sit there, and now I can tell that these are opposites of each other, so I'll cancel these out by adding, and of course that's going to give me -2y equals -2. When you divide, y equals 1. And you can take that and plug it back into either equation up here. I'm going to choose the top one just because I can see it. So that's 4x plus 2 times 1 equals -14. Of course, that's 4x.